Hello, this is Team 6 with our DHCP presentation. Nick wasn't able to make it for the video. We're pretty sure he's still coming off of his sickness, but he should be there tomorrow for the in-person presentation. But yeah, we're going to be covering about DHCP. Go ahead and click on the next slide. So first things first, internet protocol. I think most people in this profession know what it is and know how it works, but it is just a set of numbers that identify a computer on a network and allow it to communicate with others on the network, usually four sets of three numbers that allow it to just talk with others. Go on to the next slide and we'll cover DNS. DNS allows a computer, instead of us having to type in an IP address, it allows us to simply say, I want to go to Canopy, or I want to go to Google, or I want to go to Amazon, and it'll be able to translate it over to an IP address, and it'll send us over there. It's much like a phone book, where IP addresses are the phone numbers, and the actual name of the website is the person's name. Moving on to DHCP on the next slide is Dynamic Host Configuration Protocol, which automatically assigns a computer an IP address, rather than manually doing it, which is also referred to as statically assigning it. A server assigns a computer an IP address, removing the risk of duplicates or mistakes done with the assigning of it. When it first is on a network, it reaches out to the server responds back, they talk to each other, and then the computer gets an IP address given out by the server. I'm on the next slide, and we can see the differences between static and DHCP addressing. For DHCP addressing, it is very well suited for larger kind of networks that need to be assigned an IP address. Usually 30 or more was said in the book, but generally just giving out a lot of IP addresses in a set amount of time, just generally being able to do it automatically without any risk of duplicates or mistakes. Another thing DHCP excels at is allowing users to bring their own devices onto a network without having to go through configuration, say for laptops, PCs, phones, or tablets. And it allows someone to set up a network very, very quickly with a low amount of just having to configure. All you do is just configure a server and do the wiring. This differs from static IP addressing, which takes a little bit longer, but some devices on a network don't really need their IP addresses to change. DHCP operates on a lease system, which means that when the lease is over, the IP address is gone. This is not the best case for things like routers, servers, or VPNs, which need the IP address to stay the same. Small scale networks also probably don't need a DHCP. There isn't that many computers to require a DHCP to set the IP addresses automatically. And sometimes there are security standards that need to be followed, such as preventing random devices from being on the network, or you need to track an IP address. The next slide is another drawback from DHCP, where it needs to constantly be ready to accept requests. And if it doesn't, a device will instead throw up an PIPA address. Now, a PIPA address only shows up when a DHCP request is not answered or otherwise is unable to be fulfilled. Usually, it is within the 169.254.0.1 through 255 in that area. And generally, it isn't able to communicate with others on the network. It just kind of shows you that the DHCP system isn't working. And I think we can show a DHCP network on the packet tracer.
Yes, so in order to actually make a working DHCP, we can do so on Packet Tracer. The first thing we had to do is we had to just make a static address for our server so it could be found. We then went to services. We created a pool. So we added a default gateway, a DNS server. We graded a start IP address, and then we also limited the users. And to actually make these changes, you have to save them. So now anything on this network can be assigned an IP address. So if we were to go here, we'll just press DHCP, we'll request an address, and we will successfully get one. So what happens if it's not on the actual network and not plugged into the DHCP? In that case, we're going to have to use a router to then use it as a relay agent to assign DHCPs on our network. So the way we'll do this is we have to use the command line. And the first thing we're going to do is we have to press enter, enable, and then we're going to go through conf t. And this allows us to make configuration commands. And the first thing we're going to do is we need to set an IP address for the router and the eventual end device. So we're going to 68.1.1 and 255.255.255.0. And then we're going to use the helper address. You could press tab to get that command if it's close by. We'll set that to the original server. And from there, for some reason, routers are set up in such a way that all the ports are closed off. So we're going to have to hit no shutdown. And then it should open for the packet tracer. So next, we have to actually go into the end device. We have to set an IP address. It's very important to remember you have to add the subnet mask after, and as well as hitting no shutdown again. And a good way to just close out of it is just press end. Now, it's not completely ready. What we're going to have to do is we're going to have to make a second server pool. So the way we do this is the same way as we made the first one. Go into DHCP, and we're just going to start working on a new one. So for this one, we used 1 for original, or 2 for original one. So we're going to use 1 for this one. Make sure to change it there. And what you're going to do is you're going to then press add. And so what this does, it fully configures it through the server. So when we go to our PC and we try to get a DHCP address, there is a good example of a PIPA where it actually assigns a random one, but
Are they on the right interfaces?
what was that?
Are they on the right interfaces?
They should be. We could just edit this part out real quick.
Yeah.
But that literally was what it said. Anf F0. I set the IP address.
Try it again. The switch may have been down.
Okay. Alrighty. So the switch was just down. This can sometimes happen. So that's essentially the correct way to do it. We were looking through it. Everything was correct. Sometimes you just need the switch some time to heat up. So in that case, pressing the times was just not enough. And for our in-class lab, we just set up just the first part of the lab. It's not too hard. It will just be to ensure people are paying attention. It has a very detailed instructions of what it should look like and how to actually set it up. This one does not include the relay agent, but it does include a working DHCP server. So this can be completed in class. And the way we'll do it is we'll just make sure tables do it. So it's not every individual person has to do it. And it could be kind of a group project that everyone can work together on. But yes, that is our DHCP presentation.